In this video, we're going to review 5 different practice problems from section 3.2 in the book. So please have out your textbook while you follow along in the video. Number 47, this is a 4-part question. Exercise 6 from page 159, examine the relationship between the number of new birds, Y, and percent of returning birds, X, for 13 sparrowhawk colonies. Here are the data once again. They give you a table with percent return on new adults, X and Y respectively. A says use your calculator to help make a scatter plot, and then B says use your calculator's regression function to find this equation and add this to your scatter plot from line A, or part A. So we're going to use our calculators. We're going to go into stat. You're going to edit and you're going to fill in the 2 lists. This is going to be, L1 is going to be percent return, and then L2, Y, is going to be new adults. If you make your scatter plot, that's before we make the scatter plot. Let's go back to calc, and let's actually do the linear regression equation. My older calculator, you have to find the variable for y1. On the newer calculators, you won't need to. I'll store it into y1, and this is the equation for the regression. So part A, part B. Part B, you're finding the equation, so we're just going to copy this down first. So it's going to be y hat equals 32.15, we'll say. There you go. And then it's going to be minus, move this up, minus 0.31 times x. So that's the equation. If you want to graph the equation, that's why we store it in y1. If you're going to make a scatter plot, go to stat plot, so second y equals. Make sure it's turned on. The first one is selected. Make sure your y list is L2. If not, make that change. Go to graph. Mine's already zoom 9'd, but if you did not do that yet, you press zoom, and zoom 9 is zoom stat. So it automatically zooms in for the window. So we have a negative association here, hence the negative slope of our linear regression. And part C says, explain in words what the slope of the regression line tells us. So in words, the interpretation of the slope. So here's what you could say. For each increase of 1 in the percent returning birds, the predicted number of new adult birds, new adults, we'll say, new adult birds will decrease by 0.31. And we know it's a decrease because it's a negative slope. D says calculate and interpret the residual for a colony that had 52% of its sparrowhawks return and 11 new adults. So part D, 52% of the sparrowhawks return, so my X is 52, my Y is 11. So the residual, remember, is your Y actual minus Y hat. So we need to figure out what the predicted Y is. So take this value, 52, and plug it into that equation. So Y hat is going to be 32.15 minus 0.31 times 52. And when you do that in your calculator, you get 16.092. So the residual is going to be 11 minus 16.092 and you're going to get negative 5.092. So the calculating the residual is done here, but it does say calculate and interpret, so we can throw down a quick sentence really briefly. So in this colony, there were 5.092 fewer new adults than expected. Based on percent returning birds. Should always reference that based on portion of the sentence in your interpretation. Okay, that was 47. Let's go on to 49 now. So number 49. Okay. 49 says, refer to exercise 47. Use your calculator to make a residual plot. Describe what this graph tells you about the appropriateness of using a linear model. So, we have our original scatter plot here. If you want to make this into a residual plot, go back to your first plot here. Keep it on scatter plot, but then Y-list. You're going to change this to residual. So I'm going to go back to my list function. And then you have all these L's, and then the residual at the bottom. You want to choose residual, so that way it knows to make a residual plot. And I'm actually going to delete or turn off that line. So graph, we'll zoom 9. Okay. So that's our residual plot. This would be our linear regression model here, and these are all the scatter plots around it with the residuals being the vertical distances. It says, describe what this graph tells you and about the appropriateness of using a linear model. So what you're looking for here is there a curvature that you can't normally see in a regular scatter plot, and a residual plot will show you. I don't see any curvature whatsoever. There's a big scatter here. There's no overall curvature pattern going on. So you could say the residual plot shows no curvature, so the linear model is appropriate. And point A, that's part A. Part B says, which point has the largest residual? Explain what this residual means in context. So, if you're looking at the largest residual, probably go to trace. And finding if we're looking at this graph correctly. Largest residual is most likely this point right here. So try and find that. Okay. Maybe it's 68%? Trying to find the largest residual here using the trace function on the calculator. All right, so this currently isn't working, but I can tell you that the answer in the book says the largest, or the point with the largest residual is 66% returning. So 66% returning has the largest residual. So this means that the colony with 66% returning birds has about 6 fewer new adults than predicted based on the percent returning. So that residual of -6 means the colony with that many percent returning has 6 fewer new adults than predicted. So when you have that negative residual, it's less than expected based on the model itself. Okay. Next up we have 51. Let's look at 51. The 51 says a study of nutrition in developing countries collected data from the Egyptian village of Nahia. Here are the mean weights in kilograms for 170 infants in Nahia who were weighed each month during their first year of life. So it gives you a table. Age in months is your X variable, and then weight in kilograms is your Y variable. A hasty user of statistics enters the data into software and computes the least squares line without plotting the data. The result weight is weight hat equals 4.88 plus 0.267 times the age. A residual plot is shown below. Would it be appropriate to use the regression line to predict Y from X? Justify your answer. And if we can bring over the camera to show the actual graph, the residual plot, let's do that here. Okay, so here's the residual plot from problem number 51. And it asks, is it going to be appropriate to use this linear model? And if you look at the residual plot, there's a clear curvature here. Okay, let's try and get this together. Okay, there's a curvature right here. You might have a linear part right here, but that clear curvature shows you that the residual plot, that the linear model is inappropriate for this. There's a model out there for this type of data set. Just a linear least squares regression line is not it. So you're going to say that this is a inappropriate use of the least squares regression line. So it's inappropriate to use the least squares regression line because the residual plot shows a curvature. Okay. 55. 55 has to do with Olympic figure skating. This says, for many people, the women's figure skating competition is the highlight of Olympic Winter Games. Scores in short programs X and scores in the free skate Y were recorded for each of the 24 skaters who competed in both rounds during the 2010 Winter Olympics in Vancouver, Canada. A regression analysis performed using this data. The scatter plot and residual plot follow. The equation of the least squares regression line is y hat equals, I'll write this down, y hat equals -16.2 plus 2.07x. And they also give us the standard deviation of the residuals, 10.2, and then r squared is 0.736. Okay. So part A says, calculate and interpret the residual for the gold medal winner Yoona Kim, who scored 78.5 in the short program and 150.06 in the free skate. So using the equation from above, the X is the short program and the free skate is going to be Y. So if we're finding the residual, Y minus Y hat, we're going to use this equation, -16.2 plus 2.07 times, and 78.5 was the X value. So using our calculator, we're going to -16.2 plus 2.07 times 78.5. Our predicted value of y is 146.295. So that was the predicted score. The actual score was 150.06, so the residual is the difference between those two. And this is going to be a positive residual. So 150.06 minus the predicted value gets you a residual of 3.765. And the interpretation is the free skate score was 3.765 higher than predicted based on a short program score. So the free skate score was 3.765 points higher than predicted based on her short program score. Okay. Part B. Put this off here. Part B. Is a linear model appropriate for these data? Explain. So let's pan back over here again. Linear model, is it appropriate? So we have the line, the scatter plot given right there. They give the residual plot underneath. I don't see any clear curvature in this residual plot, so we're going to go ahead and say no leftover pattern of the visual plot, so then therefore it is a appropriate model. So no curvature in the residual plot. Means linear regression is appropriate. Part C, interpret the value of S, and then part D is interpret value of R squared. So S is, again, 10.2. And what this means is that when using the least squares regression line, we will be off typically by 10.2 points. It's an average error, you could say. And then D, about 73.6% of data, of the variation in free skate scores is accounted for by the least squares regression line. And we got that because R squared is equal to 0.736. The other portion that I would add up to 100% is not accounted for by this least squares regression model. All right, that's 55. Last one here, we have 58. 58. Number 58 says, do heavier people burn more energy? Refer to exercise 48 and 50. For the regression you performed earlier, R squared is 0.768. S is equal to 95.08. Explain what each of these values means in this setting. So, the previously done problems, R squared and S, those two variables again tell you how well your model fits the data. So, in terms of R squared, here's what you can say. About 76.8% of the variation in metabolic rate can be accounted for by the least squares regression line. And obviously the more you can account for, the higher percentage, the better the model is. Hence why a larger R squared value is better for the model overall. Our S value, standard deviation of residuals. So when using the least squares regression line, we will typically be off by 95.08 those calories per day. That's your average error. So you use that in terms of the actual values of y to see, is that a huge error window or is that pretty moderate in terms of the data?